we're going to finish up the precipitation process by talking about the third and final way to produce precipitation, and that's by fronts. A front is a boundary between unlike air masses. And now there are four types of fronts that you'll find on a weather map, and I want to show you the symbology. Here's a cold front, and a cold front is designated as one is when the cold air is advancing into warm air. So I've got the continental polar air with a greater push into the maritime tropical air. Now, a cold front is always shown on a weather map as a blue line with a series of triangles, always showing the direction of movement of that front. Another front is a warm front, and it's designated as such when it's the warm air that has the greater push and is advancing into the cold air. It's shown as a red line on a weather map with a series of semicircles showing the direction of movement. Another front is a stationary front. So we've got the meeting of unlike air masses, but at this point in time, neither is advancing. So the symbology uses both the cold front and the warm front, and it's shown on opposite sides of the line to indicate that it's stationary. Now, there is another type of front that you're not familiar with. You may not be familiar with. It's called an occluded front. And it occurs when the cold front catches up to the warm front. It's shown on a weather map as a purple line with alternating triangles and semicircles on the same side of the line. Now, I've drawn this vertically, and I've got cold air on both sides of the line. And so by the end of this lecture, you will understand what an occluded front is. I've just given you the definition right now, and I'll remind you a little bit later on. All right, so we're on the chapter called Weather Systems, and we're going to focus on a frontal weather system known as a wave cyclone. And I've got a nice simplified weather map showing a wave cyclone. And I like to define what one is just by breaking the words down. And I'm going to begin with cyclone, and everyone already knows what a cyclone is, the center of low pressure. And here we've got a center of low pressure, right, on weather map, centered over the Great Lakes region. Now, embedded within that center of low pressure are a series of fronts that tend to take the shape of a wave. And so that's what the term wave is. In its most simplest form, you have a warm front and a cold front. Here's today's weather map. I'm lecturing on September 1st, 2020. Now up in Canada, there's a wave cyclone. There's a cold front, and the low is off the map, and there's a warm front. Here in the central, well, just south of Lake Michigan, is a warm front that's become stationary, and there's a cold front that becomes stationary, and then it kind of continues on all across, basically through to California. So these can be very, very large systems, and we have some other pressure systems that are developing. And here's actually another wave cyclone with the warm front, and the cold front has become stationary. Here's a weather map from last year when I guess I was teaching this. The map is a little bit simpler, but there's a wave cyclone with the center of the low, the warm front and the cold front has become stationary. And here's actually another wave cyclone that's stationary, with the warm front is stationary and the cold front is stationary. So you see these very commonly all the time on weather maps, and during the cold season of the year that's approaching, you'll see more and more wave cyclones, and they'll be much more intense as the season progresses. Well, I want to show you how a wave cyclone begins and how it develops and how it dies out. And we're going to imagine it, moving across the United States. And I'm going to have a three-stage model. And in this three-stage model, we're going to incorporate all four types of fronts that I introduced. And I'm going to begin with a stationary front. And this is, like the birth or the beginning stage. And the way you get this whole low pressure system going is by the meeting of unlike air masses. And so what I wanted to show you is that neither is advancing at this moment. So somewhere maybe in the central United States, we've got continental polar air coming on down, and then we got warm air, maritime tropical coming on up from the south, and they're meeting, and neither is advancing. Now, this is the thing that gets this whole wave cyclone going. And remember, it's a mid-latitude phenomena. It's only found, in mid-latitude locations where you've got the meeting of unlike air masses. All right. Now, the next stage, we are going to make a wave cyclone. And we're going to spend some time on the mature stage. And in this stage, we're going to talk about how you create precipitation at the cold front and the warm front. All right. What's going to wind up happening in this model is we're going to have the cold and warm air starting to advance. And as they advance, they're going to form cold and warm fronts. And with the pushing of the frontal systems, it's going to start a counterclockwise circulation, a low pressure center that intensifies. So we're showing the cold air advancing, creating a cold front, right? And then we've got a warm front advancing where we've got the warm air pushing. And this starts to create a counterclockwise circulation, and we start to form a center of low that will intensify. Here's a map from your textbook, and it's a very nice map. It's got a big center of low just south of Lake Michigan, and all the isobars showing the center of the low. And then embedded within this cyclone, we'd have a cold front and a warm front that's taking the shape of a wave. And what we're going to do is take a look at a cross section on the ground through the troposphere from A to A prime. And so on the bottom, here's A to A prime, and we're going to begin in the cold air sector. Then we're going to look at what's going on at the cold front and how precip is produced at the cold front. And then we're going to move through what is called the warm air sector. All right, the warm air sector is shown here in orange, and that's that area, kind of a triangular area in between both fronts. And then we're going to look at what's going on at the warm front and how precipitation is produced there. And then we'll move back into the cold air sector. So that's what we've got here. All right, the cold air, the cold front, the warm air sector, the warm front, and then the cold air again. Let's take a look at the details of a cold front. We've got kind of a block diagram showing, cold air advancing into warm air. All right, cold air is dense, so it stays close to the ground as it's advancing from Canada. Now, as a result of the cold air advancing and staying close to the ground, you wind up with a frontal face, right? That is pretty steep. That's going to cause the warm air in advance to be forced to rise along this cold frontal boundary rapidly. And it's a rapid uplift along this wall of cold air. And what winds up happening is you wind up getting the air to rise adiabatically. Again, it's going to be the dry adiabatic lapse rate and the wet adiabatic lapse rate. But the cloud type most associated along the leading edge of the cold front are a whole line of cumulonimbus clouds, and they're only showing one here, but usually they're just lined right on up, all right? And so typically with a cold front, you get thunder and lightning and a relatively narrow line of cumulonimbus clouds. Now, that line along the leading edge of the front where you get that warm air forced to rise pretty rapidly as the cold air is advancing, it's called a squall line. And it's often shown on weather maps, all right? Weather radar. And you can always tell, the strongest thunderstorms, in the red or the purples. And so it's usually a pretty narrow line. It usually moves through pretty fast. And it's usually thunder and lightning. And once it passes, you're going to have cold and dry air associated, with the cold air from Canada. All right. Yeah, and so here we've got a diagram showing that, the warm air forced to rise rapidly as the cold, dense air, stays close to the ground, and the cloud associated with cold fronts. All right. Okay, so we're going to move into the warm air sector, and we've got the warm air advancing. And what we're going to do now is look at the contact on the side view, in the cross section, where the warm air is meeting the cold air. All right, so this is where the warm front is, and this is where the warm front is on the ground in the troposphere. So it's the exact meeting point where the warm air is meeting the cold air. So you can see that the warm front shape is very different from that of the cold front. So let's take a look at a block diagram of a warm front. And again, right here is the contact where you would see the warm front put on a weather map. All right, now warm air is advancing, and warm air expands and is less dense than cold air. So what winds up happening, even though the warm air is the one that's advancing, it's going to be the one that's lifted. The cold air is denser, and it's going to stay close to the ground. And so it's pushing, it's advancing slowly, but the warm air is advancing slowly, but also being lifted, all right, up and over the cold air. So you wind up with this low sloping feature of a warm front. Yes, and what winds up happening is you get broad, gentle lifting, over hundreds or even thousands of miles of, warm air rising and cooling adiabatically over this cold surface. So the type of cloud associated with a warm front is very different than that of a cold front. It's all different types of stratus clouds, those layered blanket-like clouds. And so the cloud deck usually, right, in advance of the warm front, usually extends hundreds of miles, right, in advance. And so this is another big difference than between a cold front. Usually you have, with the cold front, you've got a narrow squall line of thunderstorms that, move on through, and that's it. With a warm front, you wind up with the lifting, right? And so usually maybe 1,000 miles ahead of the warm front actually moving through, you've got, the highest clouds, the cirrus, and then, as the warm front is approaching, maybe the next day, you'll get cirrostratus. The clouds will get thicker, but the clouds are going to start to get lower as that warm front is advancing, and then you'll move into mid-level altostratus. And then as you're getting closer, classic stratus clouds. And then when you're very, very close to the thickest clouds where the warm air is being lifted, you'll wind up with nimbostratus. Right? And so you wind up, and again, the type of rain, too, out of stratus clouds is kind of like moderate rain. You don't usually get big thunderstorms. It's usually kind of on and off, light to moderate rain. And that just it's kind of a nuisance kind of rain, especially when you're driving. You got to turn your wipers on and off, and it's kind of a pain. All right, yeah. Here's a satellite image just showing the cloud cover associated with a wave cyclone, and you can see the whiter the cloud tops. I mean, those are the tall cumulonimbus clouds, and it's a relatively narrow band. So we're showing the squall line that, is narrow and moves through, usually pretty rapidly. Now with the warm front, right, right here, you can see that a higher white cloud tops. And so this is, where you've got nimbostratus. This is where you've got the rain coming. And then you've just got the stratus, right, the altostratus. I think we've got some cirrostratus and some very, very thin cirrus clouds, hundreds and hundreds of miles in advance of the warm front. All right, we're going to move on and make a couple of statements. Now, as the low is tracking in the westerly winds across the United States, the cold front is traveling much faster than the warm front. And the reason is, the warm front is slowed down because the warm air is advancing. At the same time, it's being lifted, and it slows it down tremendously. Whereas the cold front is just kind of bulldozing right on through as the cold air in contact with the ground and just causing that buoyant air to lift very rapidly. And so they're actually showing on this map the track of the low. over maybe the next day, right? And you can see what's happening is the cold front has actually, narrowed that warm air sector, and way up closer to the low where the winds are stronger, we've actually caught up and we've created an occluded front. Now on this one weather map, they're not showing it purple. I don't know why, but they've got the symbology of the cold front and the warm front on the same side of the line. And so I guess sometimes, you see it this way, but most ways on weather maps you see it purple. And so classically, because the cold front is advancing faster than the warm front, that warm air sector is getting smaller and smaller and smaller as that warm air is being lifted until finally, usually, in the northeastern United States or in eastern Canada, the cold front finally catches on up. And so you've got the warm air sector getting smaller and smaller, and eventually they're showing the occluded front. And the warm air sector is gone. It's all been lifted. And so this is what I was just saying. When the cold front catches up to the warm front, we wind up creating an occluded front. So let's take a look at the details of an occluded front. So here's a block diagram showing the cold front has caught up to the warm front. And as that cold air was advancing and narrowing that warm air sector, all of that warm air has been lifted. And so this represents the dying stage of a wave cyclone. Now, what we wind up with is cold air and cold air, all right, at the surface. And so we've eliminated those surface temperature differences, and the whole thing is eventually going to rain out, lose all of its moisture, and just wash off a weather map. It is the dying stage. Now remember, what got this thing going in the first place was, the meeting of unlike air masses. That's what got the circulation going in the development of the wave. Now, after several days of moving, in the westerly winds, we've eliminated those surface temperature differences, and the whole thing is just going to die out. So the occluded front represents the dying stage. And actually, an occluded front, really does represent kind of two fronts in one. It really is a combination of the cold front and the warm front. And then all that warm air sector has been lifted. And that's kind of a key characteristic of the occluded front, that the warm air is no longer at the surface, right? No longer at the surface. And here's the other diagram from the textbook showing the cold air catching up to the warm front. All the warm air has been lifted, and you wind up with various types of stratus clouds, right? Now, if this occurs in winter time, this would be a big snow producer, all right? Big snow producer, And so you get a large area, a really broad area of rain or snow, and usually just kind of it lasts for days and days and days, just kind of usually sitting over an area, with a low circulating around. And so this darker area is showing the rain shield associated with the occluded front. And it really is quite miserable weather. It's cold because we're in the cold air sector, right? It's cold, and it's just on and off rain that could last for a week or more. All right, so it really is quite miserable weather. I grew up in upstate New York, and I hate occluded fronts. I absolutely hate them. Yeah, and so they are. The thing that why you've never probably heard of an occluded front is they're not really common in Louisiana. Now, we do get them. We do get them. I saw a nice one last winter, and it's usually pretty bad weather for a week. And you'll just see the low just circulating around over Louisiana, bringing cool and rainy weather. But most commonly, they occur in the northeastern United States. As these systems begin maybe at the Rockies, and then develop into the wave cyclone, and as this whole thing is tracking in the westerly winds, the cold front is catching up to the warm front, become occluded in the northeastern United States. So that's really where they're most common, in New York and New England, and here we got it in southeastern Canada. And another place is the Pacific Northwest of the United States. A lot of times the wave cyclones begin off of China, believe it or not. And they track across the Pacific Ocean, and they develop the wave, and then the cold front is advancing faster. And by the time they hit the Pacific Northwest of the United States, they often come in occluded. And again, bringing abundant, miserable weather to the Pacific Northwest of the United States. Yeah, and I've just got some weather maps showing some occluded fronts here in the Northeast. So there's the warm air sector, and so the warm air sector is all gone now. It's all been lifted, all right, as that cold front has advanced and caught up with the warm front. And here we've got the correct color on the weather map, and that's snow, all right? So that's snow and rain, and you're just going to have the low circulating around. And then we got our narrow band of the squall line. And then we got abundant rainfall and snow, all right, over a very broad area, over hundreds of miles, associated with the lifting of the warm air over the cold air. All right. Here's a nice weather. Oh, and also, yeah, here's another example, okay. In the Pacific Northwest, we've got an occluded front coming in where it's, developed as it's advanced across the Pacific Ocean. And here's another weather map kind of showing the same thing, the occluded front. And here we've got another one coming in. It's going to hit the Pacific Northwest of the U.S. All right, so these are all pretty common features on weather maps. All right, so we've just gone over the birth, mature stage, and kind of the death of a wave cyclone. But I do want to mention 3 other features. And, as I've already kind of mentioned, and you've seen on the weather maps I've shown you, these are very large weather systems, usually involving at least 1/2 of the United States. Either you're in the cold air sector, you're in the hot and humid warm air sector, or you're getting the squall line and thunderstorms, or you've got the cloudy weather, all right? You're waiting for the clouds to get lower and lower and lower, and that warm air to advance to your location. So typically, at least, right, a cold front is usually at least about 2,000 miles in length, all right? And you've seen them. I mean, they can even be 3,000, but maybe on average they are about 2,000 miles. So they're quite long. And I remember one time I was leaving my home in Albany, New York, and the flight, I was kind of worried about it because a squall line was moving through. And but we were able to take off. There was a violent squall line with thunderstorms and lightning, whatever. But we were able to take off, just in time. And then we got up, and about 4 hours later, I land in Baton Rouge or New Orleans, wherever it was. And again, the pilot comes on and says, we're going to have a really bumpy landing because the squall line is moving through. And I said to myself, my God, it's that darn same squall line, that's 2,000 miles long. And but of course, I'm still here, and we landed safely. But anyways, there is a classic weather sequence of wave cyclones. Now, frontal systems and wave cyclones are just going to start beginning to hit us in the southern United States, as Canada is starting to get colder, and it's going to be pushing cold fronts and cold air, further and further south. And so our winter weather is kind of like a roller coaster ride, of warm and humid air. It's hot, and we're always waiting for the cold front to come through and the squall line to move through with the thunderstorms, and then it'll be beautiful weather. We'll get that Canadian high. And so, that roller coaster ride, it really is just associated with the classic weather sequence of the passage of a wave cyclone. And so that's our weather, our winter time, starting, they really get started by October and pretty much finish off by May. But anyways, on this weather map, just the way we've got us positioned, I want to pretend that I'm X here, okay, in New York, right? And I want to ask you, right, is it cold where I am right now, or is it warm? It's cold. It's cold on the ground. Remember, the contact between the warm air and the cold air is right here. And so this is all warm at the ground in the warm air sector, but the warm air is being lifted, all right? So right now, it's cloudy. I've got some sort of stratus clouds, and it's cool. Now, as this warm front is approaching, the clouds, of course, are going to get lower and lower, and then we're going to wind up with, the nimbostratus, so we'll start to get some rain, and so then we're going to wind up in the warm air sector. Right. So it depends on the season, how warm it is, but if it's in summertime, it'll be that empty air, and everyone will be complaining about how hot and humid it is in the warm air sector. And then you can get it in wintertime. And that'll usually bring temperatures above freezing for them, all right? So you get the warm air sector, right? And so you'll usually have that for a few days. And for us, we're usually in the warm air sector for a long time, waiting for that squall line to move through. And so then you'll get that narrow squall line move through associated with the cold front, and it'll push on through. And then we'll have the cold air sector. And we'll have cold and dry and clear conditions for a few days until the next one comes. And then we'll have the warm air sector, the cold, all right, the cold front and the cold air sector, and on and on and on. And so that's why we have highly variable weather, all right, during our winter months, because precipitation is all from frontal systems, all from wave cyclones in Louisiana. And so the third thing that I do want to say is that you only find wave cyclones in middle latitude locations, because it is the only place on Earth where you have the meeting of warm and cold air. So these are also very common in Europe. And so in summertime, Canada isn't really that cold. So usually kind of, southern Canada and the northern United States, gets wave cyclones all year long, all right? And so they wind up with highly variable weather all year long. And there was kind of when you get the warm front, cold air, warm air sector, cold front, and what have you. I mean, it's kind of a joke. I grew up in upstate New York here in Albany, and it really is incredible how variable the weather is, associated with these wave cyclones. And there's kind of a joke that they say, because the weather is so variable all year long, they say, if you don't like the weather, wait a minute, all right? But all right? So for us here in Louisiana, we start to get the fronts, really, getting going in October and starting to die out in May. Usually by May, they're, kind of don't make it quite to Louisiana. So here's the winter pattern, and that's going to bring our highly variable weather, all right, during our winter months, all right? Warm air, cold air, warm air, cold air. That ends this lecture.